Okay, so now let us start with the binomial distribution. Now, binomial distribution means it has only two possibilities, that is either success or the failure that I had explained. Okay, so now before moving to the actual problems of the binomial distribution, let me clear a few more points of the probability. It is one thing we saw that probability of any event lies between 0 to 1. That is what probability of any event E is strictly greater than or equal to 0. Okay, that is the one thing. Okay, and this is the first very important part. That is what you cannot get a probability negative that we had seen. Okay, and the second thing is if there are any events E1, E2, E3, or anything, okay, then the sum of all those probabilities is equals to 1. Okay, I'll just explain this. If suppose um, event is getting 1 on a die, okay, second event is getting 2 on a die, third event is getting 3 on a die, fourth event is getting a number great equal to or greater than 4 on a die. Okay, now these are independent events. Okay, and also they are not going to affect each other. That is, this is E1, this is suppose E2, this is E3, and this is E4. Okay, now what is the sample space of this event E1? Now see, the sample space of this E1 is what? Event is getting 1, therefore the sample space is 1. Now in this case event is getting a 2, that means what is the outcome which is required? That is 2. Now here it is 3, the favorable outcome I would say for E3 is 3, and for E4 it will be what? 4, 5, 6. Alright, any number greater than or equal to 4. Okay, now if I suppose this now are my sets. Okay, now if I take the union of them, that is E1 union E2 union E3 union E4. Okay, that will union will be what? The all these sets will be brought together or grouped together, and what will it give me? 1 2 3 4 5 6. Now if I go to see, this is the sample space of a die, right? That is what? All the outcomes, all the possible outcomes of this die are being covered within this, right? So now when such of the cases occurs that all the possible outcomes of any experiment are covered, then the probability of that is probability of E1 plus probability of E2 plus probability of E3 plus probability of E4, this comes out to be 1. Okay, that is what? The summation of all probabilities is equals to 1. Now let us verify it. Okay, what is the probability of E1? See, there is only one favorable outcome, that for it is 1 by 6. Probability of this E2 is again 1 by 6, probability of E3 is again 1 by 6, and probability of this 4 E4 will be what? 3 by 6. Okay, so if I go to check this, it is 1 by 6 plus 1 by 6 plus 1 by 6 plus 3 by 6. This comes out to be 6 by 6, that is 1. Okay, that means all are, that means this is also satisfied, and probability of each of the events is strictly greater than or equal to 0. Therefore this is also satisfied. Okay, so basically we have to keep in mind that the probability of even is sum of the all the probabilities of that random experiment is strictly equal to 1. Okay, when this E1 intersection E2 is equals to 5. That also we need to keep in mind. Okay. No need to keep it in mind. This is a total mathematical stuff. Okay. There's no need to keep in mind it in that way. But see, now the E1 intersection E2 will be nothing. Okay. There is no such event which will give 1 as well as 2. Okay. Also, there is no such event which will give 1 as well as 3. Yes, therefore this E1 intersection E2 intersection E3, they are 5. Okay, that is what, it is an empty set, nothing lies between that. Okay, when such of the conditions are occurring, the summation EIs will give you 1. Okay, now this is giving 1. Now if I see at it like, uh, suppose event is getting a 2 on a die. Okay, getting a 2 on a die. Now the event probability of this, now this is my E1 event, probability of getting E1 is, suppose, 1 by 6. Not suppose, it is actually 1 by 6. Okay, now what will be the E2 is my event such that event is not getting a 2. Okay, not getting a 2. That is what not getting a 2 means. What? Getting what? Getting 1, 3, 4, 5, and 6, right? Now what will be the probability of this event E2, since these are its favorable outcomes, total 5 favorable outcomes, therefore 5 by 6. Okay, now E1 and E2, if you go to check them, it is a set in this Venn diagrams. You might have seen already Venn diagram. Okay, now there is nothing common between them. It's exactly opposite to each other. Okay, getting a 2 and not getting a 2. Okay, such kind of events are called as complementary events. Okay, there's nothing less common between them. For example, getting an odd number and getting an even number. Okay, that does not lie anything in between them, but if you combine them together, it will give the whole sample space. For example, even numbers, odd numbers, or on a die. Okay, what will be the even number set? 2, 4, and 6, and odd number sets will be 1, 3, and 5. Okay, now in this intersection of this is equals to 5, sorry, is equals to 5. Okay, but if you go to see, if you go to check the union of them, entire 1, 2, 3, 4, 5, 6, that is what entire sample space has been covered. Okay, that means this event of getting an even number and this event of getting an odd number are complementary events. Okay, and if you check the probabilities of them, that is what, the probability of this even number will be 3 by 6, that is half, and probability of getting this odd number on a die is also 3 by 6, that is half. And if you add both these probabilities, this half and this half, that is half plus half, that will give you 1. That is what summation of these probabilities of these events comes to 1. Okay, now similarly in this case, probability, see, event is getting a 2 and event is not getting a 2. If you bring this together, the two of this and all the remaining favorable outcomes of this, that is 1, 3, 4, 5, 6, this is a sample space in itself, the entire sample space. Okay, that's why this event E1 and this event E2 are my complementary events. And also if you check the probability of E1 plus the probability of E2, that is 1 by 6 plus 5 by 6. 1 by 6 plus 5 by 6, that comes out to be 6 by 6, that is 1. Okay, so this condition is also satisfied, that the summation of probabilities of events is equals to 1 when the events E1, E2, E3 are the complementary events. Okay. Now see, these are even often termed as, sorry, like this. Now probability of even, now see, even is there and another event which is not even, that is termed as even complement, that is even and a CA as a superscript. Okay, so we have seen that probability of even and probability of not even, that is what probability of even plus probability of even complement is equals to 1. Okay, so can I have a formula like P probability of even complement is equals to, I'll take this on the other side, 1 minus probability of even. Okay, so now see, if I consider an example, probability of getting a number 3 or getting a number 2 on a die. Probability of this is what? 1 by 6. Okay, and the probability of not getting a number 2 is what? 1 minus 1 by 6, that is 5 by 6. Okay, so this I can directly from here see. Okay, it is verified. Okay, so now if I use this in case of binomial distributions, now see, this binomial distribution, what I had said, that it has only two outcomes, that is what? Success and failure. And these are two complementary events. If this getting a success is a even and getting this failure means what? Not success. Okay, that is what even complement I can treat it as. Okay, so the probability of this success is represented by a small p, probability of this failure is represented by small q. This is a universal representation. Okay, small p and small q. Now see, if we go to see this even and even complement, that is what? Success and failure are the complements of each other. That is nothing less in common between them. Either it is a success or a failure. There is nothing into the intersection. Okay, so therefore again even intersection even complement is equals to phi, that okay, and also there are only two possibilities, that is success and a failure. Therefore even union even complement is equals to my entire sample space. Okay, there is only two events, so therefore it is so. Okay, therefore in this case these are my complementary events, I can treat them as success and failure. Therefore when this is the case, what happens? Summation of their probabilities, that probability of even plus the probability of even complement is 1, that we have seen. And what is the probability of even? That is the probability of success, that is p, plus this probability of even complement is q, that is the probability of failure, that comes out to be 1. This is the most important thing which we will be using throughout. Okay, so it is, this binomial distribution is only dealing with this equation. Okay, that is only dealing with the success and failure. Now only dealing with success and failure means dealing with p plus q is equals to 1. Okay, now this is something like, if suppose I have two trials. Okay, now there are two trials therefore of any experiment, that is about tossing a coin. How many, if suppose two coins are tossed, two coins are tossed simultaneously, or one coin is tossed twice, that is one and the same. Okay, I'll just repeat this. Two coins are tossed simultaneously and one coin is tossed twice, that is one and the same. Okay, so basically there are two trials of that experiment. Okay, that is my n is equals to 2. Now whatever it will be, when it is tossed once, you will get either head or a tail. What is the probability of getting a head? Half. Now suppose my success is getting a head. What is my failure? Not getting a head. Okay, that is what same as getting a tail. Okay, not getting a head means not getting a tail. Okay, now what is the probability of this success? That is, what is the probability of getting a head? That is represented by small p, since it is a success. Yes, remember. So what is the probability of that? That is half. Yes, the probability of getting a head when a coin is tossed once, it is half. And what is the probability of not getting a head, or the probability of getting a tail, is also half. Okay, that is what q is also half. That is a failure. Probability of the failure is also half. Okay, now I'm tossing the same coin second time. Okay, now when I'm tossing a coin second time again, now the first one I have kept aside, I'm tossing it second time. Okay, now when I'm tossing it second time, what is my probability of getting a head? It is again half. That is, my p is again half. What is the probability of not getting a head? It is again t. Probability of getting a tail, that is q, that is again half. Okay, that is what my p and q are not changing when I am tossing the coins. Okay, even if I am tossing a coin third time, my p and q will remain same. That is what my probability of getting a head or my probability of getting a tail will remain the same. Okay, so this is what the assumptions in this are. Each trial has only two possible outcomes, that is success and failure. Okay, and the probability of success denoted by p and the probability of failure denoted by q remains constant from trial to trial. Okay, and the third assumption is all trials are independent of each other. What you are getting in the first trial is not affecting whatever your result will be in the second trial or the third trial. Okay, this is what these assumptions means. Now these assumptions are important. Now suppose if by chance the question comes, write a short note on binomial distribution, you will have to include these assumptions. Okay, and short, yes, these assumptions will be important if such kind of question comes. Okay, now about the formula. Now how to calculate the probability of this. Now suppose there are n trials as you said, and let's see with this example. Okay, now the formula for this is probability of getting r successes. That is, like, suppose the question is of getting a success is of getting a head. Okay, then the r successes means what? Getting r heads. Okay, now this is given by n factorial upon r factorial n minus r factorial p raised to r q raised to n minus r. Okay, now n is what? Number of trials. That is what, if I consider this example, see, a coin is tossed twice. That is what? Number of trials n is equals to 2. And if I want to find the probability of getting one hit, okay, probability of getting one head. My success is what? Getting a head. Okay, and getting how many heads? One heads. That is one success. That is what R is equals to 1. Okay, I'll write it here. That means how it will be? Probability of one success is, and it will be given by n factorial n minus r factorial into r factorial p raised to r q raised to n minus r. N, you know, n is what? 2. 2, therefore 2 factorial. R, you know, R is 1, therefore 2 minus 1, that is 1 factorial. R is 1, therefore 1 factorial. P you have found, P is equals to half, therefore half raised to R. R is what? 1. And Q is what? Again half, therefore half raised to n minus R, that comes out to be 2 minus 1, that is 1. So this comes out to be 2 factorial is 2, then it is 1 factorial into 1 factorial is 1 into half into half. So this comes out to be half. The total probability of getting one head is half. And if you go to check this by our earlier examples, when it was tossing a coins give the outcome head, head tail, and tail. The probability of getting one head was half. Okay, so these things are verified. Okay, let's go to a proper example. Such a simple example won't appear in the exam. Now see the question, most common question of this type. What is the probability of getting one head when a coin is tossed 4 times? Now, a coin is tossed 4 times. That is what the trial. What is the experiment? Experiment is tossing a coin. And how many times it is tossed? 4 times. That means what? Number of trials is 4. Number of trials, that is n, is equals to 4. Okay, let us say what is my success. Success is what? Getting a hit. Okay, and how many successes we want? It is how many hits we want? 1. Therefore my R is equals to 1. Okay, now success has been found, R has been found. What else is required is the probability of success, that is my p value. Okay, now what is this p value? What is the probability of getting a head when a coin is tossed? See, what is the probability of getting a head when a coin is tossed? That is 1 by 2. That is for sure. Thereby, because I'll repeat this again, there are only two possibilities, head or tail. Therefore, when a coin is tossed once, the probability of getting a head is 1 by 2. Therefore, my p value is 1 by 2. Okay, now next is about my probability of failure, that is represented by q. Okay, and we have the relation what? P plus q is equals to 1. Okay, therefore q is equals to 1 minus p. Therefore I'll have this 1 minus p. Therefore 1 minus, what is my p value? That is half. That is half. Okay, that is q is equals to half. You can take this directly, q is equals to half, from this calculation this way as I showed. Or when the things are easy, probability of failure in this case is what? Not getting ahead. Not getting ahead means what? Getting a tail. And what is the probability of getting a tail when a coin is tossed once? That is half. Okay, therefore q is equals to half. Both ways, assuming it both ways, then you will get the correct answer. Okay, p is equals to half, q is equals to half. This we have got. Okay, now what is my formula? What I need to check? Probability of r successes. Okay, that is what? Probability of 1, I can say. Okay, or I can say x is equals to 1 or anything. Okay, you can just represent it by p of 1. Anything is fine. Okay, now it is given by what? N factorial n minus r factorial p raised to r q raised to n minus r. Okay, now this thing, p raised to r, I have all these values. Okay, so what is my n? N is 4, therefore 4 factorial. Then n minus r, r is 1, n is 4, therefore 4 minus 1, that is 3 factorial. And what is r? Again, r is 1 factorial. And p raised to r, that is half raised to r, that is 1. And q raised to n minus r, that is half raised to 4 minus 1, that is 3. Okay, now I hope I am using this term for factorial. I hope you are clear with this term. 4 factorial means 4 into 3 into 2 into 1. 3 factorial is 3 into 2 into 1. Similarly, n factorial is what? N, the next term n minus 1, the next term n minus 2 till 1. Okay? Okay, so I'm assuming that you know this. Now, simplifying this, it will be what? 4 into 3 into 2 into 1. Okay, divided by this part. 1 factorial is 1 itself. Then 3 factorial is what? 3 into 2 into 1 into this part, that is half, and half raised to 3. Okay. Now if I go to check this, I can cancel out this, I can cancel out this. It will be like 4 into 1 by 2 into 1 by 2 cube. 2 cube is what? 8. Okay. So further cancelling this out, it will be what? 2 here, it will be 2 here, 1 here, that is 1 by 4. So basically my probability of getting one head is when a coin is tossed 4 times is 1 by 4. Okay. So this is how your problems will be, the most common example of the problems. Now similarly, if you wanted to check in the same example, what is the probability of, sorry for this, what is the probability of getting 3 heads? Now in this case, what is that? R will be equal to 3. There is 3 successes. Therefore, what you need to calculate? Probability of x is equals to 3. So in this case, what will be? Your n will remain same, that is 4. Your probability of success will not change, that is half. Your probability of failure will not change, that is half. Only your formula will change, that is n factorial, n minus r factorial, p raised to r q raised to n minus r. So only the value of r will change. That is what? 4 factorial upon 4 minus 3 now. R is 3. So therefore it is 1 factorial into this one will be 3 factorial, and this answer will come back to the same answer according to me. Half raised to r. R is what? 3. And q raised to, that is half raised to n minus r, that is 4 minus 3, that comes out to be 1, and this value will come back again to 1 by 4 if you solve this further. Okay, so this is the most common examples. Now again, similarly, probability of 2 heads. Now this one will change. Probability of 2 heads, that means what? R is equals to 2 now. Okay, so in this case, what will be? Probability of x is equals to 2. It will be n factorial, n minus r factorial into p raised to r, q raised to n minus r. So in this case, it will be what? 4 factorial. Now n minus 4, sorry, n minus 2, that is 4 minus 2, that is 2 factorial into r is 2 factorial, half raised to square, q raised to 4 minus 2, that is again 2. Okay, now this comes out to be 3 into 2 into 1 upon, sorry, this one will come out to be 4 into 3 into 2 into 1 upon 2 factorial is 2 into 1, that is 2, into 2 factorial is 2 into 1, that is 2, then 1 by 2 raised square, 1 by 2 square. Now this one will come out with this 2 will cancel with this. Now this one will be 3 into 2 into 1 upon 2 square is 4, 2 square is 4, 3 by 8. Okay, this probability of getting 2 heads will be equal to 3 by 8. Okay, so this is how your examples will go. Now I'll just say one more example here. I'll just try to solve one more example. Suppose a bag a bag contains 6 white and sorry 6 white and 4 green balls. What is the probability that in 6 drawings with replacement? Now this word is important, with replacement. Exactly 4 white balls are drawn. Okay, now for solving this, you need a knowledge of probabilities also properly. Okay, now see, the question is about drawing 4 white balls or getting 4 white balls. Okay, so my success is getting a white ball. Okay, now how many times you want that to happen? How many successes you want? 4. Therefore r is equals to 4. Okay, and in how many drawings? Drawings means what? Removing. Okay, you are removing it, so your removing is your trial. Okay, your experiment is removing the ball from the bag. Okay, so your trial is drawing, that is what? N is equals to 6 number of trials. Okay, now you know what is a success, what is your r value, what is your n value, that you know. Now you have the formula, probability of x is equals to 4 is given by n factorial n minus r factorial p raised to r q raised to n minus r. Now to use this formula, what you need? P and Q. That is the probability of the success and the probability of the failure. Okay, once you know the probability of success, you can find the probability of this failure, that is Q, by easily by this equation, P plus Q is equals to 1. That is Q is equals to 1 minus P. Okay, so let us see what is the probability of getting this success, or what is the P value. Okay, so for that we need to read this. A bag contains 6 white and 4 green balls. Okay, now 6 white and 4 greens. Therefore, what is the total number of balls present in the bag? That comes to 6 plus 4, that is 10. Okay, so total number of balls is equals to 10. So my total number of outcomes is 10. Okay, so this value I have found. Now that one ball is removed, what is the probability that it is a white ball? Okay, now that is what the number of favorable outcomes. Favorable outcomes are 6 in number, 6 white balls. This you know quite well. Okay, so what is the probability of getting a white ball? 6 by 10. That is what? 3 by 5, I can say. Okay, probability of getting a white ball, that is my p value, probability of success is 3 by 5. Now from this I can find a q value, that will be 1 minus p, that is 1 minus 3 by 5, that comes out to be 2 by 5. Okay, now I know the value of r, now I know the value of n, I know the value of p, I know the value of q, therefore I can use this formula very well. Okay, so now probability of getting 4 white balls in 6 trials will be probability of x is equals to 4, and that will be given by n factorial. Therefore, 6 factorials, n is 6. Yes, so 6 factorial. 6 minus 4 factorial. 6 minus 4 factorial into 4 factorial into p. P value is what? 3 by 5. 3 by 5 raised to 4 and 2 by 5 raised to 6 minus 4. Okay, so this comes out to be 6 factorial. I will just split this 6 into 5 into 4 into 3 into 2 into 1 is my 4 factorial. You try to convince this yourself. Okay, 6 into 5 into 4 into 3 into 2 into 1. Okay, out of this what is this? This is my 4 factorial. Therefore 6 into 5 into 4 factorial. Okay, now 6 minus 4 is 2 factorial, that is 2 into 1, that is 2. Okay, into 4 factorial as it is. Now what is this? 3 by 5 raised to the power 4 and 2 by 5 raised to the power 2. Hmm? So I can cancel out my 4 factorial here. I can cancel out my 2, that is 2 with this 3. So what I get is 3 into 5 into 3 into 3 raised to 4 into 2 square. 2 square is what? 4 upon 5 raised to 4 into 5 square, that is 25. Okay, out of this I can cancel this, I can cancel this, that gives me 5. And what does this final answer comes out to be? I think it comes out to be something like 432 by, I doubt on this answer. Okay, so whatever you answer you are getting as a fraction is your final answer. Okay, it will be something 5 raised to 5 into, it will be what, 3 raised to 5 into 4. Okay, whatever answer you get is your final answer, the probability of getting 4 white balls into 6 trials. Okay, so this is all about your binomial distribution. If you need more problems I can solve some and send, but this was all about your binomial distribution. Now if the question is about getting at least 4 balls, getting at least 4 white balls, that is what, getting 4 is fine, getting 4 balls is fine, 5 white balls is fine, and getting 6 white balls is also fine. Therefore, the probability of this, probability of getting 4 balls plus the probability of getting 5 white balls plus the probability of 6 white balls will give the probability of getting at least 4 white balls, right? 4 or more is fine. Therefore, how will be your formula? Probability of x is equals to 4 plus probability of x is equals to 5 plus probability of x is equals to 6. Okay, that is what, r value will be 4 here, r value will be 5 here, r value will be 6 here. Okay, rest all will remain same. That is what it will be, in this case it will be what, 6 factorial. Now only, obviously only 6 white balls is remaining. Only 6 white balls is possible. Why? Because the entire box contains, or bag contains, only 6 white balls. Okay, otherwise it could have gone further. Now, okay, so probability of x is equals to 4 will be 6 factorial upon 6 minus 4 the whole factorial, 4 factorial. P, you know that probability p value will also remain same, p raised to 4 q raised to 6 minus 4. Okay, plus it will be, for this part it will be 6 factorial, then 6 minus 5 factorial, okay, into 5 factorial, again p raised to 5 q raised to 6 minus 5, that is 1, okay, plus for this part it will be 6 factorial upon 6 minus 6 factorial into 6 factorial p raised to 6 q raised to 6 minus 6. And if you solve this further, this value you know, plus this will be what, 6 into p raised to 5 q plus this one will be 6 factorial 6 okay. Now 6 minus 6 is 0 factorial, and 0 factorial is mathematically defined to be 1. Okay, don't write it as 0, it is 0 factorial is 1. Okay, so this will be 1 into p raised to 6. Okay, and p value you know, okay, probably that is p value is 3 by 5. Okay, so when you solve this further you will get a exact answer. Okay, that will be your final answer of probability of at least 4 white balls. Okay, this was just a second sub question which I solved from the first. Okay, okay, so this is how you solve this binomial distribution. Thank you.